Here's a quick recap of the notes on the law of cosines. Don't have the law of cosines? Let's write them out. This is page 326 in your book. So if you remember anything about the law of cosines, make sure you remember that there's a relationship between the letter that you start with. So you're going to start with the side. So if we know sides A and B and angle C, then what we're missing, what we would start with, is side C. That's how you know. The angle and the side that are across from each other will be at opposite ends of the formula. So this would be C squared equals A squared plus B squared minus 2. Then you use those same two letters, A, B, times, of course, the cosine of C. So it ends in a capital C, it starts with a lowercase c. So you can apply this to really anything. The idea is that you know the pattern. You don't have to specifically apply it to A, B, and C, or X, Y, and Z. So if we end with angle A, then you know we're going to start with A squared. This equals B squared plus C squared minus 2BC times the cosine of angle A. And the third and final version of this would be B squared equals the other two sides. So if we have B there, then the other two sides are A squared and C, and you square that, minus 2AC cosine of B. So there are all the formulas. You will never be given those formulas. So when do you use the law of cosines? How do you know that you should be using the law of cosines? Simply by looking at the information given. Take a look at number 3. In order to use the law of cosines, what is the minimum information needed? Well, that's kind of, I think you could explain that a lot of ways, but I'll just tell you to you this way. You need more sides than angles. So what does this mean really? If you have side, 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 that's more sides than angles. It's a lot more sides than angles. If you have side, angle, side. So if you have these two patterns, one of these two patterns in your triangle, then you will be able to use the law of cosines. So check it out. Let's do some. So when do you use the law of cosines? You got more than one side, and you know what else you don't have? You don't have a right triangle. No, it's true. No right triangle. So you can't use cosine, you can't use sine, you can't use Pythagorean theorem, you can't use 30-60 because of the 90, and so you don't really know what to do. So take a look at number 4. There's a courtyard at Ghirardelli Square in San Francisco. It's going to be triangular. They're looking for how long the retaining wall would be if these are the other measurements. So if we just take a look at the information we have side, angle, side. So we have more sides than angles. So we are looking for this, which we could call X if you'd like. I'll put it over here. Don't really give you a lot of space. This is problem number 4. So we're going to start with X squared. Then we're going to have 45 squared plus 30 squared, the other side. These are in no particular order. Any order is good, either order. 45 or 30 being first. Minus 2 times 45 times 30 times, of course, the cosine, let me slide this over, of 105. It's all about that. Since we knew the 105, we started with the side opposite that. Now, when you type this in the calculator, you are not going to get the answer. When you hit enter and you put in 45 squared plus 30 squared minus 2, you put all this in, cosine of 105, hit enter, you are going to end up with the letter squared. You get some big answer. Do not copy that down. In your calculator, because we're going to take the square root, and you should not copy the decimal down, you should not round the decimal, you should not change the number at all. So because I don't want you to touch that number, we're going to leave it in the calculator. So we're going to go second to get to the radical sign. Then we're going to go second because we want to get to that ANS. That is the key above the negative. Not the minus, but the negative. And what is going to happen on your calculator, it's going to be square root, and then it's going to say answer. So on the screen, that's what it'll look like. And the calculator is taking the square root of the most recent answer, saving you the time it takes to write down all that stuff. So we get 60.198 yards. Just like that. We're going to skip number 5. Is this exact same thing? You can see the pictures over there to the right, side angle side. So not much different. Take a look at number 6 though. The space they give you is just awful. So we'll try to make it work here. So the Escape from Alcatraz triathlon includes a 1.5-mile open water swim from the island to the aquatic park. So from the island, they swim 1.5 miles. Due to the strong currents, the swimmers aim for a tower, located 0.3 miles upshore from where the aquatic park is. So they aim for this tower, which is 0.3 miles away. These are all in the same unit. And that park also happens to be on a straight line measurement, 1.25 miles from Alcatraz. They're looking for the angle between the course the swimmer set and the actual course that they swim. That's this angle right here, right? Because this is the course that they set, and the currents pull them over here. So we're looking for that little angle. You can tell it's little. It's also across from a very small number. So we would anticipate a very small angle. Now, I'm not talking like 0.2 kind of small, but I'm expecting to be probably less than 20 degrees. Just due to the lack of space, I'm coming down here. This is side, side, side. And of course, you can tell we have more sides than angles. So because we want this angle, we are going to start with 0.3. 0.3 squared. Now the other two sides, it doesn't matter what order you do this in, 1.5 squared plus 1.25 squared minus 2 times 1.5 times 1.25 times the cosine of the missing angle. You're missing an angle. This is an inverse cosine situation, cosine to the -1. So inverse on your calculator. We'll get to that in a minute. So because this is all stuck together, you approach this problem differently. We need these numbers. 0.09, that's 0.3 squared. Add all this together. Put this in the calculator. 1.5 squared plus 1.25 squared. Don't round it. 3.8125. We want all of it. Now, this problem is right here. This is our situation. This number is stuck to the cosine, and we need it in its entirety. So put that in the calculator. Now we're just solving it. So you're going to subtract 3.8125 from both sides. You cannot do anything with these two numbers on the right-hand side because one is stuck to the variable. You can't add them. Don't you do it. So on this right or left-hand side, we get negative 3.7225. Got my calculator today, haha. And so on this side, negative 3.75 cosine x. Divide both sides by negative 3.75. Don't write this down now. And when you do that, you get a big decimal. Decimal. Don't write any of the decimal down. We want the calculator to give us an angle. So now you're going to go second cosine because we want the inverse. Second answer again because we want to have the calculator take that decimal and tell us what the angle is. We get angle x equals 6.943 degrees. Now because we're dealing with triangles that aren't right triangles, you may forget some of your triangle geometry stuff. Take a look at number 8. Oh, hi. Two sides of an isosceles triangle have lengths 12.2 and 5.8. Why is there only one possible triangle? So we have an isosceles triangle, meaning two sides are equal. And they're telling you there's only one possible triangle with this combination. So what's the combination? Is it the 12.2? Whoa, that matches? Or is it the 5.8? Putting the 12.2 down here. In a triangle, the sum of any two sides has to be bigger than the third. Has to be. Otherwise, you don't have a triangle. So in this triangle, if I add up 5.8 and 12.2, that's bigger than 5.8. If I add up 5.8 and 5.8, uh-oh, that's not bigger than 12.2. So this triangle is not possible. So the reason is, again, the sides have to be 12.2, 12.2, 5.8, because the sum of any two sides has to be greater than the leftover or the third side, or you do not get a triangle. I just can't go out in the yard and pick up 3 sticks. Doesn't always make a triangle, and that's why. All right, now I'm on page 328, and we're going to do number 9. This is pretty typical of how the problems will be written. You'll have to draw your own picture, and you'll have to kind of understand what they're talking about here. So let's take a look at number 9. 2 ships leave a dock at the same time. They travel in straight lines. The angle between the ships is 52.1. Here's the dock. Ship travels in a straight line. Ship travels in a straight line. The angle between them, 52.1. One ship travels at a rate of 15.8 miles per hour. 15.8 miles per hour. That's not how far it went. I'm just trying to keep track of my information. And the other one goes at a rate of 12.126. How about 12.16 miles per hour? How far apart are they after 4 hours? So the question is, this space is what we're looking for. But we know that they've been traveling for 4 hours. So miles per hour means I can take my 15.8 times 4, and I get 63.2. That's the distance. That's miles now. And then I can take the other one, 12.16 times 4, and this distance is 48.64. And again, that's in miles. So now if you take a look at the triangle, it's a side angle, side triangle. This is law of cosines. So since we're looking for that, this one sets itself up pretty well. So we're going to have x squared is what we're starting with. This might not all fit. Let me slide it over. So x squared equals your two sides. It doesn't matter which one comes first. 48.64 squared plus 63.2 squared minus 2 times these numbers multiplied together, 48.64 times 63.2 times the cosine of 52.1. Put that in your calculator, and as you know, you're going to go second square root, second answer. And you get that x equals 50.83 miles. That's part A. Whoa, wiggly. Part B, let's take a look at it. After 4 hours, all right, so that's where they ended up. This is the 4 hours. They changed direction and sailed directly toward each other. If they maintain their same rates of travel, how long will it be before they meet? Oh, how did that? I'm not too happy with that. Our picture stuck to the screen. Okay. Well, we can deal with this. Let's just make a new picture. So basically what we have now is that we know that the ships are this far apart, right? After 4 hours, one landed here, one landed here, and this is 50.83 miles. Now I'm going to go back to their rates. How fast are they traveling? Right, because I want to know how many hours it will take for them to go that far. And if they're traveling at each other, then their total distance will be 50.83 miles. So for part B, I'm going to go 15.8, I don't know the speed, x, plus, I don't know the hour, sorry, 12.16x has to equal 50.83. So this is pretty easy. Add this up, 27.96x equals 50.83. And of course you divide by the 27.96, which you wouldn't have to write any of that. And you get x equals 1.82 hours. I hope having been able to watch it yourself has made it a little bit more clear. Your assignment is right here. You can see it. It's 11, 12, and 13. So if you don't have your book, here you go. 11, 12, and 13. Scooch it down so that you can see all the questions. Bye-bye.